el sol saliendo sobre el mar y a la noche del día escapar. Mira el mar que se bautiza en luz y en la arena vuelve a descansar. La hay un reino en este lugar. Es mi reino de Victoria Bay. Mira el viento que juega en el mar, inventando su vuelo al pasar. Mira el alma que se echa a volar, cual gaviota de Victoria Bay. Hay un reino en este lugar. Es mi reino de Victoria Bay. Hay un reino en este lugar. Es mi reino de Victoria. Donde puedo el alma deshojar, donde siento la noche llegar, donde espero al viento con su paz, en mi reino de Victoria Bay.
ema reka ele morena kawena reka ema ratswarana morena urihoge liseding rechoroge waar die wilgers welig spruit doringboom sy skadu sprei soos ons groei in kundigheid mag U ons vlei sien ons hoe hier lei met die hand laat U sien rus oor ons land. Three strong streams united flow, Africa stands proud and tall. As we learn, we trust, we know God is in control. Bless us, O Lord, guide us with grace. May Northwest be blessed always. Bless us, O Lord, sien ons hier. Orite Jehovah Morena, sien ons, bless us, O Lord.
Good evening, distinguished guests, friends and family of Pieter van Zyl, and all colleagues and old students and so on. Ek het vir Pieter ontmoet in 1996, 97 daar rond. Ek weet dit maak ons oud, maar ja, dis wanneer ons ontmoet het as 'n medestudent. Ons het redelik vinnig vriende geword. En later ook kollegas in 2008, as ek reg onthou, het Pieter by die skool vir chemie en fisiese en chemiese wetenskappe aangesluit as 'n mede-kollega. In hierdie 25 jaar periode, die tyd vlieg verskriklik, maar dit is hoe lank dit al is, het ek ook baie goed bevriend geraak en vertroud geraak met nie net Pieter nie, maar ook met sy direkte gesin, ken sy kinders baie goed, sy vrou, sy ma en sy aangetroude familie almal. En ek was vir 'n lang ruk ook is ek deel van die familie. So ons is huisvriende ook en kollegas. So. Ja, natuurlik, ek het die troukar ook bestuur. So toe Pieter my gevra het of ek vanaand se openinge vir hom sal open, het ek dit met nederigheid en dankbaarheid onmiddellik aanvaar. En in die gesprek wat ons daarna gehad het in die kantoor vir so 'n paar minute, waar ek hom gevra het wat hy graag wil hê ek moet doen, of moet ek sommer in die algemeen praat, moet ek uit die Bybel lees, wat wil hy hê ek moet doen, toe het hy vir my baie eksplisiet gevra dat ek moet asseblief open met skriflesing en gebed. Hy wil erkenning ook gee op die manier aan ons Hemelse Vader, wat hom natuurlik die krag gegee het om te doen wat hy doen, en dit het my toe ook verbly om dit te hoor. So in die tyd wat daarna gevolg het, die paar dae, het ek nou na 'n paar versies en so aan gaan soek, wat ek gevoel het miskien van pas sal wees vir so 'n geleentheid. En uiteindelik het ek afgekom op versies, en ek gaan dit in Engels lees, uit Lukas 12, Luke 12 verses 8 to 12. There was a gathering where Jesus spoke to thousands of people, and to give some background and so on. And then Jesus said, verse 8, I tell you, whoever publicly acknowledges me before others, the Son of Man will also acknowledge before the angels of God. But whoever disowns me before others will be disowned before the angels of God. And everyone who speaks a word against the Son of Man can be forgiven. But anyone who blasphemes against the Holy Spirit will not be forgiven. Verse 11, when you are brought before synagogues, rulers, and authorities, do not worry about how you will defend yourself and what you will say, for the Holy Spirit will teach you at that time what you should say. So die feit dat Pieter wou gehad het, ek moet met skriflesing en gebed open, het vir my ook net weer bevestig dat hy nie skaam is om sy hemelse Vader te erken in sy weg en in sy weë wat hy gestap het en sekerlik nog vorentoe gaan stap ook nie. Goed, ek sluit daarmee af, dan net met 'n gebed. So ek gaan dan net bid en dit gaan ek ook in Engels doen. Dear Lord, thank you for bringing us together this evening to celebrate with Pieter, Cecile, and their sons this beautiful occasion. Thank you, Lord, for all the blessings you bestow upon us, as well as all and the ample opportunities that you put us up in our lives. Thank you for being present tonight, and because of your presence, we would therefore ask you to bless this proceedings tonight. Lord, please bring everybody safely back to their homes tonight after the proceedings, and please guide us in our daily lives so that we may operate and do things that will make better versions of ourselves. We ask this not for whatever reason. We ask this out of grace and in the name of Jesus Christ. Amen.
Deputy Vice-Chancellor, Professor Darrell Balia, the Executive Dean of the Faculty of Natural and Agricultural Sciences, Professor Mudise, fellow academics, distinguished guests, ladies and gentlemen, good evening and welcome to the inaugural lecture of Professor Pieter van Zyl this evening. I also wish to welcome the following colleagues from our faculty and family members of Professor van Zyl. Starting with Professor Henning Grill, the Director of Chemical Resource Beneficiation, Professor Christoph Venter, who is the Director of Space Science Research Group, Professor Annette Combring, who's a Northwest-University Member of Council, as well as being the mother-in-law of Professor van Zyl. And then also we wish to welcome, of course, Professor van Zyl's wife, Cecile, and their two sons, Professor van Zyl's mother, as well as Professor van Zyl's family, friends, colleagues, and students who made the effort to be here, and especially for those that came from far. I also wish to welcome everyone joining us virtually via live stream, but especially a few people who could not be here. And I'll list them. Ernst and Judy Bovey, Professor Paul Bieckers and family who are joining us from Australia, Professor Kobus Pinar and his wife Mart Pinar who are joining us from the Western Cape, Professor Ernst Breed. We are indeed honored and excited to be once again welcoming another top and highly achieved professor to our faculty, and we are looking forward to the very fascinating inaugural lecture ahead. Thank you very much, ladies and gentlemen. I will now call upon Professor Modise to give an introduction to the speaker.
Good afternoon, family and friends, or is it evening? Prof Darrell Balia, the DVC of IT and Poch, Deputy Dean, Prof Medupi, all directors from the faculty, and family and friends, as well as family and friends overseas. It is indeed my pleasure and honor to introduce to you Prof Pieter van Zyl. I will read his biography. After receiving his PhD degree in 2007 in physical chemistry, Peter was permanently appointed as a senior lecturer in the School of Physical and Chemical Sciences at Northwest-Universiteit in South Africa. He was promoted to associate professor in January 2018 and to full professor in January 2022. So you can actually see that he made very good progress in a very short time because of his academic prowess. After his appointment at the Northwest-Universiteit, himself and Professor J.P. Bieckers took over the management of the Atmospheric Chemistry Research Group, which I will refer to as the ACRG onwards, from Professor J.J. Pinar, who was the former Dean of the Faculty of Natural Sciences. Under his management, the ACRG has focused on multidisciplinary approaches to identify problematic atmospheric species, as well as establish sources and deposition mechanisms of these species. In 2019, the ACRG was included as the atmospheric node of Biogeochemistry Research Infrastructure Project, BioGRIP, a research infrastructure platform of the South African Department of Science and Innovation within the framework of the South African Research Infrastructure Roadmap. Of which Peter is currently the node manager. Under Peter's co-leadership, the ACRG has attracted substantial funding from industry and government to fund research activities. 17 PhD and 25 MSc studies have been completed under his supervision or co-supervision. That is quite impressive. While there are currently 5 PhD and 2 MSc students registered under his supervision or co-supervision. He has supervised 3 postdoctoral fellows and is currently supervisor of 1 postdoctoral fellow. He has authored and co-authored 86 research articles published in peer-reviewed journals and 3 book chapters. He also authored and co-authored 46 peer-reviewed conference proceedings, delivered 17 oral presentations as the presenting author, co-authored 82 oral presentations as the non-presenting author, as well as authored and co-authored 110 poster presentations at various national and international conferences. Peter has an extensive national and international collaboration network. He currently is convener of the steering committee of the International Global Atmospheric Chemistry and World Meteorological Organization. Endorsed international debits, which is the deposition of biogeochemical important trace species project, while he also served as co-chair of the steering committee of the IGAC Southern Hemisphere Working Group. He is currently a member of the thematic technical committee on meteorology and atmospheric science of the expanded freshwater and terrestrial environmental observation network, EFTEON, in South Africa. He is principal investigator in the European Union, H2020, MSCA RISE project of Integrated Nitrogen Studies in Africa, INSA, which is a multidisciplinary consortium of European and African partners. He was also the principal South African investigator in a large EU-funded FP6 project, which is the European Integrated Project on Aerosols, Cloud, Climate, and Air Quality Interactions from 2008 to 2011, as well as in the, this is a French name there, CNRS, that is Atmospheric Research in Southern Africa and Indian Ocean, since 2012. Furthermore, he is also principal investigator and co-establisher of the Velgagroen Atmospheric Measurement Station, a comprehensive, permanent, long-term air quality and climate change relevant station in South Africa. Colleagues, you can see for yourself that Prof Peter has been very, very, very busy, and he's done really, really well, and he's done the faculty very, very proud. Ladies and gentlemen, I would like to present to you Prof Pieter van Zyl. Thank you very much.
Ekskuus Ashley, so dis nie nou die wat is
Colleagues, a very important part of this ceremony is the actual recognition of him as a full professor by draping him.
Okay, now I'm dressed. Thank you, Professor Modise, and then I just want to log into my computer, and thank you for all of you being here. Those who come from far, I really appreciate it. It's difficult to travel in these days. I know domestic air travel is very difficult, so for all of you that are here tonight, I really appreciate it. Okay, so one of my colleagues, Stefan Siebert, said this is like giving class. So hopefully I'll get into that lecturing mode during this inaugural. And I must say it was quite a strange address to get your mind around. I mean, I've attended many, I've enjoyed many, I've found some of it very boring. So it's very difficult to have this talk. If you go to an international conference, you know what the audience is like. So I decided tonight to make it a personal matter because this journey for me has been quite personal. and personal meaning the people, me and the people, my close people that are close to me, that surrounds me every day. So the title, No Man is an Island. We are connected through the atmosphere. As an atmospheric chemist, you expect the obvious. We breathe the same air. This guy is going to focus that we all are connected through the atmosphere. But I decided I would rather like to focus on the other obvious meaning of this saying, no man is an island. That is the interconnectedness of people, how we as people are interconnected. I heard this phrase the first time from a Gary Larson joke. I don't know if you know Gary Larson. He's a very famous American cartoonist. Andrew, you know Gary Larson, sort of. My sister-in-law loves Gary Larson. And in this cartoon, so he's a very famous American cartoonist. He's also an environmentalist, much in the same line as someone like Jane Goodall. And in this cartoon, he literally portrays a man as, or he shows the absurdity of a man as an island by literally portraying a man as being an island inhabited by a tribe. So that is always one of those Gary Larson cartoons that stuck with me through my entire career. Students, there's two of my best mates sitting there, Lawrence and Maynard. You know, we read Gary Larson jokes over and over, but this one stuck with me. Now, my mother-in-law would be proud of me. I'm not a professor in English. I did a Google search. So, students, not very good. I mean, you remember Paul and I will always tell you, never Google search. But since I'm not going to dig into English literature, I did a quick Google search. So this is, in fact, one of those quotes that is not Shakespearean. It's not a Shakespearean quote. It was actually by a person, John Donner, and please correct me, do you know this name? Apparently he was one of the greatest metaphysical poets of the 17th century. And this famous phrase, no man is an island, is the title of a poem that he delivered during a sermon when he was dean of the St. Paul's Cathedral. And dictionary.com, again, sorry, not Webster or some better dictionary, no one is self-sufficient. Everyone relies on others. So that for me is the crux of this inaugural. And I just took some audience comments on the Google search. It's about the concept that the man is a social being. He needs the contact and interactions with others. And I love this. When he is in an isolated state, he does badly. I think COVID taught us all that. You know, we suffered on our own. I'm actually struggling to reintegrate with society again. Okay, so it's about the connectedness of people. And thank you, Colin, for that beautiful opening. And our interconnectedness, of course, with God. So therefore, in my inaugural address, I'm going to journey or explore my journey as becoming a professor through focusing on the people that influenced me. I'm going to talk about my atmospheric chemistry research through the main collaborative projects or programs that we participated in. And then, of course, I'll show you some highlights of my research in which the interconnectedness of us all through the atmosphere is illustrated. And of course, how we as humans are changing the chemical composition of the atmosphere. So yes, it starts here. That's the foundation. A solid foundation was laid at home, in the home where I grew up with. Mom is smiling now big. She doesn't like being on the big screen. So she and my father and my sisters, Amanda, Lindy, and Annalise, this is the house in which I was molded. And I thought about it, can one say scolded, Mom? Yes. I grew up in a very strict house. But that is the person who I am today because of that foundation that was laid there. We were always encouraged. We were always supported. We couldn't have asked. We didn't have much. I realize in the South African context, our privilege, we still were, but we weren't rich. and my parents gave us all the opportunities, and it frustrated my mother that I never stopped studying because she always wanted me to go work. And as soon as I finished the one degree, I'm going to do the next degree, and that was very confusing. Mom, here I stand. I think I finished studying now. Okay, and then, of course, the new foundation. I mean, they are the people that make me get up in the morning. Well, literally make me get up in the morning with a shout or someone. I mean, that is the life source. They are the rock. They are the people that for who I do what I do. If it wasn't for them, life wouldn't be worth living for me. So my wonderful wife, Cecile, Pieter Jacob, and Emil, all of them are here. These two are a bit older. These were taken in 2019, the last art club in Potch. And then, of course, if you get married, you're lucky or unlucky, but your family get expanded. And I couldn't have asked for better in-laws. My wonderful mother-in-law, Prof Annette, Ma Annette, my sister-in-law, Louisa Marie, and her son, Louis. And of course, my brother-in-law, Jaco, and his wife, Sophia. There they are again on their way to Safari, Namibia, or wherever. And they've always been also wonderfully supportive. Lawrence and Meinhard. Meinhard is, by the way, the only person that came from Cape Town who made the effort to be here from Cape Town, and I really appreciate it. Meinhard, I took that picture that you sent the other night, sorry. He made a joke and he said he will send something better. He didn't. So, I mean, I have other friends, but these friends are my close friends. My brothers, they are more than friends. I mean, Lourens, this is Lourens and his wonderful family, Carly and their boys, and Meinhard and Colin, who opened up everything. So Colin you'll see again. Colin is a friend and a colleague of mine. And yes, we bribed a lot, especially when we were students. Colin, when you still lived at that small holding. Broken Pot exists because of us, I think. With Lourens, with Meinhard and Colin, you know, having a couple of beers after a day's work. And then my students know, I always shared my hobbies with them. PlayStation and especially FIFA is a favorite passing time of mine. So thank you for Meinhard and Lourens for Friday evenings that we can PlayStation and FIFA. And I must say it's necessary. After a rough week, it's just a distraction what one needs. And of course, friends, I think illustrates no man is an island as good as anything. Then to get back to my career path, I had the wonderful teacher, Meneer, I'm going to call him Meneer Bovie. I'll never call him Ernest Bovie, but Mr. or Meneer Bovie was my physical science teacher. He is the reason that I became a chemist. He was the one that inspired me. It's not that he told me, Peter, you must become a chemist. It was just the way he conducted himself in the classroom. He always made chemistry interesting, but he was more than a chemistry or a physical science teacher. He also always gave us life lessons, which I still think of today. And then he was also funny. I'm not a social media guy. I'm not big on Facebook. But every Monday I get some notifications from Facebook. And these are the ones that I actually read. Meneer Bovie's jokes. He was always funny. And that also always clever humor, quirky humor, clever humor that made you think a bit. And then I'm also in the privileged position of having two people that I regard as academic fathers, Kobus Pienaar and Prof Breed. Even though I am a prof now, I'll never call him Ernst. Prof Ernst Breed is like a father. Kobus, me and him have a different relationship. But these are my academic fathers, and they were more than supervisors. Of course, their influence on becoming a professor is very obvious, being my supervisors for my postgraduate studies. But they were more than that. They were friends, they were confidants, and between the two of them, something that I took into my research and supervising other students is to be meticulous when it comes to attention to detail. So I had two wonderful academic fathers, and of course Kobus trusted me to, when he was dean, to make me, together with Paul Beekes, co-manager of his atmospheric chemistry group that he started. So I'll always be thankful for these two people. And yes, unfortunately, none of my fathers can be here today, and I completely understand, but what a wonderful privilege to have these people in your life. Then I must mention one of my colleagues, all of your colleagues, don't worry, Stuart, Kobus, Henning, I love you all, but I had a bit of closer colleagues in my career. And Paul Beekes was just, he's listening now. It's now what? It's almost 1:45 in Perth where he is now. I'm still mad at him that he left us. But he was my partner in crime. We had the same vision. We had a shared goals. We were brothers. We were more than just colleagues. We shared each other's hardships. And Paul was just a wonderful partner to have in this whole period in the Atmospheric Chemistry Research Group, or ACRG, as Professor Modise said earlier. But he left now, and I'm very fortunate that this baton, and Paul was a fisherman. If Paul didn't work, he was catching fish. And he actually caught fish. I'll show you another photo of someone who I also know that loves fishing, but I don't always see him with fish. But Paul Beekes is caught fish, and this symbolizes that the baton has now been passed over to Corneels. And I'm very, very happy and excited about the journey forward with Corneels as a new close partner. And then a special mention must also be made of Colin Reid again. Colin, I got it from Facebook. So by the way, there's no, I don't hope there's any copyright issues here. All the photos were stolen on Facebook and WhatsApp profiles and things like that. So Colin, this is all I could get of you fishing, but like I said, next to the water. Of course, Colin was he's a wonderful teacher in chemistry and one of the best teachers at the NWU. And Colin was a great mentor when it came to the teaching and learning side of this job. And then, of course, you guys that made the effort to be here. Tracy, I didn't see you earlier. I mean, the students. Kagelo, I see you also now. I didn't see you earlier. I mean, they're really the heartbeat. They are what it's all about. And as you can see, guys, Andrew, I look for older photos. Although you guys still look good. So this is a special bunch of students. It's all the PhD students that Paul and I co-supervised. There's your Corneels. These are people that did their masters. Some of them only did their masters. Some of them are continuing with the PhDs. This is a special bunch of students, postdocs. Don't worry, Mickey, I'll show you again. You started as a postdoc in the group. And we had the Finnish postdoc, interesting guy. Kimi Räikkönen wasn't really a postdoc in our group. It was Svante. At the time, I couldn't find a picture of Svante, so I used this picture of a Formula One driver. And then Karen wasn't a postdoc, but she helped us a lot with field work. And yeah, so the students, I mean, there's this saying, the university will be a nice place without students. I don't agree with that. I think we all saw through COVID what a bad place the university is without students. So I can't testify to that. I had the most wonderful students working or doing research together. And then, of course, I see they're not here now, but I understand. I thought the guys from Joburg at least will come, but the Sasol colleagues are here. I mean, the collaborators, there's no sense in doing research on your own. No, remember, my title is No Man is an Island. You can't do research in isolation. And this, ladies and gentlemen, is the institutions that I have collaborated with in my entire career. We collaborate with national and international academic institutions. Most universities in South Africa We also have good collaboration with industry, SASL and Eskom. Eskom personnel couldn't make it. I invited some people from Gabby couldn't make it. But I'm just joking. I know those guys, it's not their fault that the electricity is not. The people that we work with at Eskom are good people, if they're listening to this broadcast. Then, of course, the SASL people, thank you for you guys coming through, Herman, and some of my old students who are now working for SASL. And then, of course, with government. We have a wonderful collaboration with environmental affairs, or what's it now, forest fisheries and environmental affairs, science and innovation, and also with our local Northwest provincial government. And this is also typically what one of our research papers look like. We always have this long author list and affiliations, because that is the way we publish, that is the way we work. Together we identify the scientific questions that we want to answer, and then we work together in solving those problems. Okay, and that is the current team. I like to call them the A team, the atmospheric team. And this is what we look like today. You have myself and Corneels being group leaders. Then we have Mickey and Lebu, who's our station and laboratory managers. We have an admin person, Mokhaetsi. Here you see Paul. We didn't throw him away. We made him an extraordinary professor. So, these are Finns. So if you just go back, so you'll see that our main collaborators are actually these people from Finland, from France, Prof Ann Thompson, she's here from the USA, and then of course also our colleagues at the NWU within the Unit of Environmental Sciences. And this is the current students, and I also invited 2 of our honor students, which will hopefully also next year continue with their masters in our group. So as I said, I would like to talk about my research through the main collaborative projects that our group was involved in, or are still involved in. First one is the DEBITS program. It's the deposition of biogeochemical important trace species, of which the African component is called INDAF, the International Network to Study Deposition and Atmospheric Composition in Africa. Then the Welgegend supersite, and then also we do other smaller projects for industry and for government. And I'm going to explore my research activities mainly through these 3 types of collaborative projects that we do. So the first project is DEBITS, or INDAF. So this is a project that already started in 1992. So Professor Kobus Pienaar was part of it when it started. And this is what we call an IGAC-endorsed program. Now, IGAC is the International Global Atmospheric Chemistry Program, which is part of the WMO, the World Meteorological Organization. And this is one of the longest programs that is encouraged by IGAC, by the IGAC program. It currently comprises about 25 sites located around the tropical belt. It was also linked to the International Nitrogen Initiative. Again, collaboration, we're fitting into other networks. And we're also currently included in the INZA, as Prof David mentioned earlier, project. And that's just about researcher mobilization. It's just about taking Africans to Europe and bringing Africans to Africa to work together. Now, DEBITS in South Africa was developed to monitor the deposition and the potential long-term impacts of important trace species in southern Africa. So the key here is we wanted to look at your carbon, sulfur, and nitrogen cycles. But the focus here is really on long-term measurements. And to provide data on deposition that can be related to impact. It's one thing to measure in the atmosphere and know the concentrations of bad pollutants is this, but what is the impact of those pollutants? And that is where your deposition work of atmospheric pollutants becomes very important. So these are the depositions or the debits, South African sites. So these sites are what we call regional background sites. Sorry, these sites are what we call regional background site, meaning it's not in proximity within or directly next to a large source. It's impacted. It's impacted by the regional impacts of atmospheric pollution. So Amersfoort, you'll see it's Amersfoort, Skukuza, and Louis Trichardt. And here's a zoomed in map. So Amersfoort, you'll see, is next to these black dots are what we call the major large point sources of atmospheric pollution in the Mpumalanga Highveld, which, by the way, is a very industrialized area. But almost all our coal-fired power plants are there. We have a petrochemical plant there. We won't call the name. We've got pyrometallurgical smelters. So this is a highly industrialized area. So Amersfoort is just next to it. So we call it an industrial background or industrial regional site. Then, of course, Skukuza, you'll know that's in the Kruger National Park. And Louis Trichardt is a real rural background site. And then when Sasol and Eskom were sponsoring this project, we also included the Vaal Triangle, which is, of course, a highly industrialized area. Not shown in this map is Cape Point. Cape Point is also part of this debits network. So debits in South Africa has since, and I can be, Herman, maybe you must correct me, but I mean, since I can remember, since when it started, it was sponsored by Sasol and Eskom. And due to financial, numerous reasons, that it stopped in 2017. But, and I don't see Gregor and Becky here tonight. I thought they were coming. Thanks to the FTON network that was now established through NRF, the National Research Foundation, this debits work will now continue. And we already signed a tender or got a tender to do this work for the next 5 years, which is fantastic news for us. So what do we measure at these sites? Again, I'm not going to give you a 101. I thought, must I give an atmospheric chemistry 101 lesson? I think most of you are learned here and have some sort of idea of what is a pollutant. It's something that's bad for the atmosphere. So what do we measure at these sites? We measure gas concentrations, and we use these passive samplers, and we measure SO2, NO2, and ozone, sulfur dioxide, nitrogen dioxide, and ozone, which are basically your criteria pollutants. Those are the ones that government is concerned about. Then we also look at the chemical composition of rain, and we measure the pH of rain, and then we also look at the chemical composition of aerosols. So if one look at pollutants in the atmosphere, you usually get two types of pollutants. You get your gaseous species, and then you get your particulates, your aerosols. And that is what we measure or collect when we typically do atmospheric chemistry or atmospheric science. Okay. So I'm going to focus on one or two studies from this debits work to show you how we are, in fact, changing the composition of the atmosphere and that we do have an effect of what's happening around us. So if one look at rain chemistry, two questions pops up. How are we changing the atmosphere, and what is the impact thereof? So if you look at the chemical composition of rain, that reflects your interacting physical and chemical mechanisms in the atmosphere. So that means the emission of the pollutant, the transport and the transformation through chemical reactions of the pollutant, and then, of course, its removal, how it gets back to the surface, either through rain or it can be just through dry deposition, also go back to the surface of the earth. And the rain, or the chemical composition of rain, reflects changes in the composition of the atmosphere due to changes in anthropogenic activities, human activities, but of course not always, it's not only human activities. Changes in meteorology and climate also has an influence on the chemical composition. And then of course you all heard of acid rain before, the term acid rain. So wet deposition is also the way that these acidifying compounds, sulfur and nitrogen, gets into the ecosystem. Okay, so I said there's going to be some proper science, and I'm really trying to get the best screen here. So this is what we determine when we analyze or when we look at the chemical composition of rain. We look at these species, and it's a very busy table. This is not a good slide to show when you're lecturing. I just want to show you from this slide is how anthropogenic activities are having an influence on the chemical composition of the rain that we measure. So the first thing that we see is that the highest concentrations at Amersfoort, remember now, Amersfoort is an industrial site, so it's in proximity just next to all those coal-fired power plants and industries in the Mpumalanga Highveld. The Vaal Triangle, you know it's in the Vaal Triangle. Herman just drove from there. He can tell you what the air looks like there. And then Louis Trichardt is a rural background site, so there's no sources in proximity. But even at a site like Louis Trichardt and Skukuza, which is in the Kruger National Park, we see that the sulfate has the highest concentration. Now, sulfur is, of course, an anthropogenically emitted or industrially emitted species. So our rain chemistry in this northeastern interior of South Africa is dominated by sulfate. And we see that the concentrations, as one expects, is 4 times higher for sites in proximity of industrial sources compared to the 2 rural background sites. Then the second and third most abundant species, which is also indicative of human activity, is nitrogen. So ammonia, that's something that is usually associated with the agricultural industry. Nitrate, that is burning, so it can be vehicular emissions. NO2, that is oxidized to NO3, but also household combustion. So if we look at the chemical composition of rain that we collected at these sites, we see that the species that dominate the chemical composition are of anthropogenic source. Okay, then we started from 2009, and like I said, 2009, the debits program was actually rebooted. And so that was what this paper was based on. And we could compare the ionic composition that we determined from 2009 to 2014 with a previous period when rain chemistry was determined. And what we see at Amersfoort and at Skukuza is we see an increase in the concentrations of sulfate, nitrate, and ammonia. And that is due to the impact of increased anthropogenic activities and, of course, population growth. So if you have increased population growth, the energy demands increase, and one of Stewart and Rudolph's students actually showed how the electricity usage in this country increased in the last couple of years. And also this, what is shown here is what we call air mass history. So it shows the movement of air mass arriving at some site or passing over a region and arriving at some site. And one can see that's Skukuza. You must remember now Skukuza is far away from these sources. That even at Skukuza, we can see that what is happening in that industrial Mpumalanga Highveld is having an impact on a site that is remote, that is distant from this region. Okay, so it seems that we are not going in the right direction. And then if we look at the pH of rain events, we see that 94% of all rain events that we collected from 2009 to 2014 had pH that is lower than the natural pH of rain. Now, the natural pH of rain is not 7 due to other processes or basically carbonates in the atmosphere. Your pH of rain is not 7. Your natural pH of rain is 5.6. So 94% of rain had pH values that are lower than natural pH of rain, meaning we're sitting with acidic rain in this part of South Africa. Of course, other questions has to be considered, such as are critical levels exceeded? Those are the type of studies that we still have to do. And if we compare to the previous studies, we also see more rain events with lower pH compared to the studies that were done in previous times. So also showing that we're not going in the right direction. Then, as I mentioned, the DEBITS program the aim of DEBITS is to do long-term measurements. So from DEBITS and these little low-cost passive samplers that we used, we obtained a 21-year, 19-year, and 16-year data sets for 3 of the South African INDOF or DEBIT sites, for Amersfoort, Skukuza, and Louis Trichardt. And we could assess long-term trends of sulfur dioxide, nitrogen dioxide, and ozone. And we studies, and again sticking to interconnectedness of my talk, we studied the interdependencies or the interconnectedness between local, regional, and global parameters. So there we look at global, regional, and local meteorological conditions, as well as source contributions through proxies that we chose. And we looked at what is the influence, what is the factor or the aspect that is causing interannual variability and the changes in concentrations of SO2, NO2, and ozone. So what we saw is, so again, I'm not going to go into too much detail. So this root mean square area means this is the difference between the actual measured value and the modeled value. And what we see here is that population growth actually had the most substantial contribution to the modeled SO2 and NO2, well, at most of the sites, which is, of course, indicative of the impact of increased anthropogenic activities. And again, I also show you that back trajectories of air masses. So we also see that the regional circulation of air masses over the Mpumalanga Highveld causes concentrations or causes population growth to be the factor that had the highest contribution to the modeled sulfur dioxide value. And then if we look at the trend of this over the 21 sampling, and I'm just showing it for Amersfoort, I'm not showing it for the other sites, but we see that there is a positive slope. That means that there, over the last 19 years at Amersfoort, there's an increase in the concentrations of SO2, and we see a similar graph for NO2. If one look at the ozone concentrations, well, we see actually that ozone concentrations remained relatively constant. However, there's large interannual variability, and that interannual variability was mainly due to the El Nino cycle. You all heard of the El Nino cycle. So that is a global factor influencing the concentrations of ozone. However, local meteorology and anthropogenic activities had an impact on the seasonal variability in ozone. This study also showed the regional ozone problem that we are sitting with in South Africa, and this is something that I'll explore a bit later through Tracy's study, which I thought is also a nice illustration of the interaction in the atmosphere. Okay, so our rain chemistry and our trend of the gaseous species shows that increased in anthropogenic activities increased population growth with an increased energy demand led to increases in concentrations of species, sulfur and nitrogen species, in this part of South Africa. I'm not going to say too much on this slide, staying on the theme of not doing your work in isolation. Our results have to be contextualized. So this is something that we always do in our work. So all these concentrations of SO2, just showing it for SO2 at Amersfoort, Louis Trichardt and Skukuza, you contextualize it with other parts of the world to see whether we have a problem, how does it fit in? So again, no man is an island. That result on its own does not make sense if it's not contextualized with levels thereof in other parts of the world. And it seems like we are comparing at Amersfoort with levels here. I think that is a site in India. Okay, so that is the first main collaborative project through which my research is done, namely the DEBITS program. So the second one is the Welgegend site. And this site started or was established through cooperation between us, the University of Helsinki, and the Finnish Met Institute. So initially, the Finns, the University of Helsinki and the Finnish Met Institute, brought into the country a mobile unit with the idea to measure at different parts in South Africa. So first, maybe I must try on this board again. So first, they placed this mobile unit at Botsalano, which you can see here is on the border between South Africa and Botswana. Then after 2 years, it was moved to Marikana. You all know the name Marikana. That is in the Western Bushveld complex, where all the platinum smelters are, chromium smelters. And also during this period, we participated in the large European Union project, the UCARI project. Here, we measured here at Elandsfontein, which you see is located right in the middle of the Mpumalanga Highveld, again with these black dots indicating large point sources, power plants, petrochemical plant, pyrometallurgical smelters. And during that period, we traveled quite a lot, and it was nice, it was fun, but I was starting a family, I wanted to be at home more, and we were looking for something closer. But we can't just put it closer because it's close to the university. There must be a scientific question that we can answer. And Laurie Larkser, that was a visiting professor at that stage, did some extensive research, and we decided to consolidate all the instruments into a single supersite, which we called Welgegend, which we now sort of realize it's not exactly where it is located, but the name stuck now. So, and it's a fun name for French people to pronounce, because our European colleagues are struggling to say this word. Sorry, Kathy, if you are tuning in, I'm talking about you. Yes, okay, so why Welgegend? Does it make scientific sense to have it there? So yes, so if you look at this slide, we see this indicated here are the major anthropogenic source regions that has an influence on air masses that we measure at Welgegend. Remember, no man is an island. What happens here has an impact on what happens here. Air masses gets transported, moved. So at Welgegend, we are able to observe all these main anthropogenic source regions. That's the Western Bushveld complex. There's Joburg, Pretoria. This is the Mpumalanga Highveld. This is the Vaal Triangle. And what we're also able to do is we can isolate air masses that pass over these source regions. And we can look at the chemical composition only of air masses that has passed over these source regions. So that's why we choose Welgegend. And of course, it also has this clean sector to the west. We have a clean regional background to the west, which gives us an idea of what background concentrations of species such as SO2, NO2, ozone, etc. is. Okay, so what is the aim of Welgegend? Is to conduct a comprehensive long-term regional measurements in order to address some of the shortcomings in the past in the atmospheric measurements. I must say that was 10 years ago. I think someone like Stuart would agree that we've, as an atmospheric community in South Africa, have answered many of these questions during the last couple of years. But we want to continue because there will always be new questions arising. And then, of course, a milestone was reached, as Professor Modise also mentioned earlier, when this site was included in the atmospheric node of the Biogeochemistry Research Infrastructure Project BioGRIP in 2020. So here's just 2 photos. Andrew, Cornelius, you remember this photo? So they had to pose that day. Sasol sent a photographer, a professional photographer. We used that photograph for many years, Andrew. But now the photographer is Mickey, so Mickey sent me this photo, so one can see how this station from this has expanded into what it is today, and it is ever expanding. This very bad slide, not going to say too much on it, it just illustrates the comprehensive nature of measurements that we are doing at this site. Okay, so from this collaborative research, I've decided that I want to focus on one study. There's a number, Kagelo, I see you, I remember the black carbon paper, what a wonderful paper that was. But I thought I would like to focus on the ozone paper because I'm also a chemist. And there are people here from chemistry, and ozone, atmospheric ozone, has all to do about chemistry. So the extensive collaborative research at Welgent, as well as during the UCARI project, and that period when the station was a mobile unit, led to a very comprehensive assessment of surface ozone in the South African interior. Now, high ozone concentrations are observed in many areas in South Africa, and we see that the air quality, the South African air quality standard limit, is exceeded on various occasions. We're seeing it in all our studies, not only in our group, other research groups are seeing the same. Now, since ozone is what we call a secondary pollutant, a secondary pollutant means it's not emitted directly in the atmosphere from the source. Something is emitted into the atmosphere, and that thing is converted into a secondary pollutant, and that is ozone. Or in this case, that is what we call a secondary pollutant. So since ozone is a secondary pollutant, you also see that high levels of ozone are not in the industrial areas or over the cities. You found it downwind from the sources. Again, no man is an island. Now, this is where the chemistry comes in. The photolysis of nitrogen dioxide in the presence of sunlight is the only known way of producing surface ozone. And the two precursor, or the main precursor species for ozone to form is NOx. NOx refers to nitrogen oxide and nitrogen dioxide. And VOCs, volatile organic carbon, and also carbon monoxide. So these two species are the main precursor species of secondary or surface ozone. And ozone production has a complex and non-linear dependence on emissions of these precursor species. So it's not a straightforward chemistry problem to solve. It is a very difficult atmospheric compound to control. So we're sitting here with complex chemistry, interconnectedness, chemical interaction that must be understood. So in order for us, and unfortunately I did invite people from our local government and from national government to be here tonight. Hopefully they are listening. So in order for us to develop an effective management plan to reduce ozone, we must determine whether a region is NOx limited or VOC limited. Then we can focus on one of these precursor species. So under VOC limited conditions, your ozone concentrations will increase with increasing levels of VOCs or carbon monoxide. And under NOx limited conditions, ozone production will increase with increasing concentrations of nitrogen dioxide. So the general rule is, in general, it's considered that ozone production in regions close to anthropogenic sources are VOC limited. So within an anthropogenic source regions, you have high levels of NOx, NO2 or NOx, NO2 that's NOx. And these, so the rule is, in an industrial area, you'll say ozone production is VOC limited, whereas in rural areas are mostly NOx limited. Okay, Tracy, now I'm showing your nice graphs. So the first thing is if we look at the seasonal, the temporal pattern, the seasonal and diurnal pattern of ozone concentrations at these sites. Remember, it is Welgegem, Botsalano, Marikana, and Elandsfontein. So we see the typical season that we see in Southern Africa. We see a late winter, early spring peak. And of course, if one look at your diurnal pattern, since, as I mentioned here, though it is formed through the photolysis of NO2 in the presence of sunlight, so your daytime photochemical ozone production always peak around this time. Okay, so if one look at this seasonal pattern that we see for ozone, we see that our seasonality is indicative of the sources of ozone. In spring, wildfires, seasonal wildfires, and in winter, increased household combustion for space heating. People burning to stay warm. Okay, so also due to extensive collaborative research, we could compile this very nice spatial contextualization of ozone. Again, that word contextualization. Ozone concentrations must be seen within context. No man is an island. So we ended up with, or Tracy ended up compiling this very nice map. And one can see that the regional problem, ozone problem, is clearly evident in this part of South Africa. Okay, so as I mentioned, so the spring ozone maximum can be attributed to increased widespread regional wildfires. We usually refer to wildfires as open biomass burning, because wildfires isn't a term that's known across the world. In South Africa, of course, we just call it veldfires. But the guy in Germany doesn't know what a veldfire is. So the spring ozone maximum that we see has to do with your increases in widespread wildfires. And here we compiled what we call source area maps. Maybe it's easier to show it here. So basically, these source area maps, the ozone concentrations that we measure at Welgegem, here at Welgegem and at Botsalano, was related to the air mass history. So we can see that this means that the highest ozone concentrations measured at Welgegem and at Botsalano were measured in air masses that passed over that region. We did the similar thing for CO. Remember, CO is also a precursor species of ozone. And we see also that the highest CO concentrations are associated with air masses passing over this region. And if one look at these fire maps, this we retrieve from satellite data with these red dots. I know it's all blurred in now. Basically, burned areas. So one see a clear correlation between ozone concentrations, wildfires, and carbon monoxide, or CO. So the regional transport of CO, and we assume, because we didn't measure volatile organic carbons associated with biomass burning, is an important source of surface ozone. Then a second thing that we did is, we looked at the correlation. In the absence of any VOC measurements, we looked at the correlation between ozone, NOx, and CO to gain some insights into ozone production. So here we have the CO concentrations plotted against the NOx concentration, and the concentration of ozone is that color scale, with red being the highest concentration and blue being the lowest concentration. So if you look at these graphs or figures, you'll see that ozone concentrations, and we did it at Welgen, Botsalano, and Marikana. We didn't have CO data for Elandsfontein. So here you can see that ozone concentrations increase with increasing NOx. Our ozone concentrations do not increase, and we see it at all three sites. But if you look at the CO concentrations, we see that ozone concentrations are increasing with increasing concentrations in CO. So that tells us that Welgen, Botsalano, and Marikana, all these sites are CO or VOC limited, even the background sites. We would have expected this at Marikana, but we see it at Welgen and we see it at Botsalano. Okay, and then I thought, just to show the chemists that we do some complicated stuff, I'm not going to go into too much detail of this complicated graph, but here, although we didn't have continuous VOC measurements at these sites, Corneels Jaars did a wonderful PhD study. Again, no man is an island. We used Corneels's data, the VOC data that he collected, what we call grab samples, over a 2-year period. And that was used to model the instantaneous production rate of ozone as a function of your nitrogen dioxide and your VOC reactivity. Without going into too much detail, this is what we call a ridge line running here. And on the left-hand side, what is here is considered NOx limited. And ozone on the right-hand side of this, figure is in the VOC limited regime. So what do we see? We see that the modeled ozone production transitions between NOx and VOC. Remember, Welgen is impacted by the anthropogenic source region, but we have the clean background to the site. So we see that 40% of ozone production, well, according to this model, 40% of ozone production that occurs at Welgen falls in the VOC limited regime. And of course, the ozone production that is in the NOx limited regime are most likely from that clean background region. So, these correlations between ozone, NOx, and CO, as well as this calculated ozone production rate, indicate that continental South Africa can generally be considered VOC limited due to very high anthropogenic emissions or industrial emissions. Not only industrial emissions, it's also vehicles, it's also household combustion in this region. And that is the information that's important for policymakers to make decisions. Then just one other study that I'd like to say. Professor, we do engage with the community. It's always a difficult question for me to answer. If they pay you to do the research, is it community engagement? I don't know. I try. So we did a very nice project for the Northwest provincial government. We worked together. We used that passive sampler. The thing about that passive sampler, it's a cheap sampler, simple to deploy, and in Northwest, lots of measurements are being done at Rustenburg, Brits, in those areas where the industries are, but not much is done in places like Taung and the rural parts of our province. And I feel as the Northwest University, we must engage with our local government. So we did this very nice project, and we also compiled these spatial maps. Without going into too much detail what it meant, basically it was shown that at none of these sites any of the South African standards were exceeded in rural areas. But again, it also shows the ozone problem that we have in the South African interior. Again, so we engage with the community. No man is an island. Okay, so that brings me to the end, ladies and gentlemen. So as I said, I could show you hours and hours of slides on the great research that we've done. We know our interconnectedness with the atmosphere. We know we are connected through the atmosphere. We breathe the same air. We know that what we are doing is changing the composition. Tonight, I'm not talking climate change, but it is real, ladies and gentlemen. Do not believe otherwise. That is, we can also go on for an hour on that. I rather decided tonight to focus on the chemistry side of it. Yeah, so this is just pictures of, I must say, the last couple of years of having fun. I hate flying. I really do. I don't mind the long flights to Europe in the big plane, which doesn't bump that much. But the small planes, we did that. And this was the fun part. Mika, one of this, what some of the students will feature here. So we worked hard. But we also played hard. And we also worked and played hard. This is the fun. If you go overseas, here I'm sitting in Toulouse watching a Toulouse rugby match. Here I'm sitting in Potch watching the Pukke play rugby, who I also love. Here I'm at Disney World with my children. They can't remember anything. Me neither. I can't remember much of that trip. And always having a beer with one of my students. Paul was always a great photographer. Me and him and Aaron Steinhans traveled. Here we were in Japan. That was a fun time. Mickey, sorry for this. You can sue me later. In a Finnish sauna. Yeah. So we worked together. We worked and played hard together. But at the end, we did it as a team. So yes, ladies and gentlemen, I stand here tonight alone, but no man is an island. I thank you. Must I now get out of the way? Leslie is so. Wow. That's my second name, Gideon. Yeah, I don't like it.
Okay, congratulations.
Thank you, Professor.
So let's dispose.
No, that's. Thank you, Professor. Yeah, it's my neighbor that makes it, Prof Louis. Dankie, Louis. Thank you.
Thank you. Good evening, Khoinan, Dumelang. Congratulations to Professor Pieter van Zyl. I just learned that he doesn't like his second name, Gideon.
Jammer maar.
I actually like it. It's more biblical to me, the one that I know.
You're right.
So when I looked at the program, Peter, I saw you didn't make provision for prayer, and you didn't say much about your family. So I imagined you to be a loner, somebody stuck in a laboratory somewhere, in a isolated office in some building on campus, somebody who's removed from the world that ordinary people like myself live in. And then that all proved to be a misconception, especially when I began to understand what you mean by no man is an island. And I think, for me, with a theological background, that was in some way, a scientific sermon that I got from you this evening. And I want to congratulate you, on this approach that you have taken to share your knowledge. It's a lesson for us all working in the university community to relearn and to understand how knowledge is procured And you know, in the old days, the emphasis was very much on independent study. You had to be alone, you had to be removed from society. I know when I was studying in Germany, I used to leave my door open, and my German colleague had a problem with that. How can you study with your door open? It's that kind of thing. And time and time again, the message you were sending to us here, those of us who are not specialists in your area, we could easily understand that you do your work with reference to people, other people, whether they're students, colleagues scattered all over the world, and with things that are happening in different parts of the world. You're not somebody who's sitting in an ivory tower. That will be the last form of description that would apply to you or to your work. So I want to compliment you for the approach that you are taking, and I want to recommend it to your PhD students and others. I may not be here, considering that there's a lot of wear and tear already there. But when they come here and give a lecture, that they would be inspired by your very unique approach to the procurement and the sharing of knowledge and understanding. But apart from that, I want to congratulate you as Northwest University on this very specialized area that you're working in. You know, over the past 2 years, we've learned a lot about ventilation and the atmosphere. I used to always think we are what we eat, but after COVID, I've begun to realize that we are what we breathe more than ever. And when I saw this topic about the atmosphere, I imagined myself, coming here, having a nap during the lecture. And then, but it was very exciting to learn about this exciting work that you are doing, and that's so relevant, for our country, for the world in which we live. When I started off as a student, because I studied theology and became a dominie, I thought I was going to save the world. But it's people like you now, with all this climate change, that are really, we are going to depend on you guys to save planet Earth. That's the message that's coming out every day, in whichever news media one is exposed to. The world is under greater threat because of the changes in the atmosphere. And it's the work you do, your students, your colleagues, that is so invaluable to our university, but to the tradition of science as a whole. So congratulations, on that achievement, to your family and friends who have helped you as you have shared with us the journey. And that's really what this is about today. It's a celebration of your life and those who have stood behind you, who have helped you to come to where you are. I want to salute the faculty under Professor David Modise's leadership, who continue. We have, it's almost, I want to say, a factory, but it's really high quality professors from this faculty who are bringing great honor, and we don't hold back any criticism, but we give praise when some of our colleagues leave us, actually, and they go to far places. And we know there are quite a few who've gone to Perth and New Zealand and to Europe from the Northwest University. So, tonight is as much a celebration of your work, the work of your faculty. But lastly, I want to say, Prof Annette, you've been, a citizen of Potchefstroom. And I was thinking today, for over 100 years, Potchefstroom, well, not you. I should maybe talk about Professor Posma and the others. But this place, this small town, this town where we are gathered here this evening, a population of less than 100,000 people. But we have been sending academics, producing professors, and sending them all over the world. And we've been doing it for over 100 years. And that is why this event is so important, to celebrate your achievement. And we know there will be many others who will come after you and that you will inspire. So again, congratulations to you and your family for this significant achievement. And we hope you will grow from strength to strength in imparting the great insights about the atmosphere and science to us. Thank you.
Thank you, bro. Thank you very much. Beautiful. Do we go off now? Ashley? Off.
Ladies and gentlemen, I am back again, but this time my task is very simple, and it is that of thanking all the people who made tonight possible. But first, let me thank Professor van Zyl for a very entertaining and enlightening talk. A mark of a great scientist is the ability to bring his or her complicated or intricate work to the level of a non-specialist and the public. Tonight, we witnessed all of this in great display. Thank you, Prof van Zyl. I'm quite certain that students who are present here and those who will have access to this lecture online will be inspired to be like you, a top scientist with a passion to share his work with others. I'm also very happy to see that many of your collaborators and students are here tonight, so I want to thank them as well for making time to be here to support you and to enjoy and celebrate tonight. As well, I would like to thank Professor Darrell Balia again for always giving very thought-provoking insights in a very entertaining way. Thank you, Prof. And I'd like to thank Professor Modise for a good introduction, as well as to thank Professor van Zyl's family for selflessly sharing him with us. My thanks also go to fellow professors and directors in our faculty for making time to come and support a colleague. I also want to thank colleagues who make the procession possible by providing the gown and providing order as well. And last but not least, I'd like to thank Ashley Pieterse for playing a very important role in organizing tonight's event. And a special thanks also to our new member of our faculty admin, Emma, our new Lizelle, if I can call her that, who will be organizing these events as a faculty secretary from now on. And above all, thank you to all of you. Enjoy the rest of the evening. Thank you.